Hey everybody, in this video we are going to talk about factoring polynomials. We're going to work our way up to solving polynomials, but in this video we're just going to focus on factoring them. We factor these big things that we call polynomials. Well, factored form of a polynomial, let's just talk about what that means. When I talk about factored form of a polynomial, that means a polynomial written as a product of multiple polynomials. So it's like we have a couple different polynomials that are all being multiplied together, and that's what a factored form is. Right? We're taking a polynomial and we're breaking it apart into a bunch of pieces being multiplied together. Just want to remind you right here, what's always the first step in factoring? We always, before we do anything, we always want to look for a GCF. Greatest common factor. Okay, we talked about that a little bit when we factored quadratics at the beginning of this course, but it's going to be really important with the things that we're doing at this point. Okay, so we always got to look for a greatest common factor before we do anything else. Very important. All right, so let's do an example of how we factor a polynomial when there is a greatest common factor. So let's say I have this polynomial right here and I am told to factor it. Okay, well, the first thing I am always going to do is look for a GCF. All right, maybe you saw this and you thought, oh, we got to do A times C, multiply first times last. But you need to take note of the fact that that only works for quadratic equations, and this is a cubic equation. Okay, so before I do anything, I got to take out a GCF. So if I look at each of these terms, I see that they're all divisible by x. So I'm going to take an x out of that, and it'll look like this. I'm going to divide x out of it. So it'll be x squared minus 4x minus 5. I just divided each of the terms by x, and now I've taken out my GCF. Okay. Now notice that this thing in the parentheses, now that thing is a quadratic, right? So now that we have a factor that is a quadratic, that's a quadratic equation, I want to ask myself, can I factor that thing anymore? Can I factor x squared minus 5x minus 5? It's a quadratic equation, so we should be able to factor it. Okay? So if we can, we're going to go ahead and do that. So I'm going to factor that thing. So it's x squared minus 4x minus 5. So I'm going to factor it. A times c, first times last, that's negative 5. Remember, this is leading coefficient of 1, so that's my easy case. My more simple scenario, I need two numbers that multiply to negative 5 and add to negative 4. And we could do negative 5 and positive 1. Okay, so in this scenario, since the leading coefficient is 1, I got my two numbers. That means I'm pretty much done. So I can factor this to be x minus 5 and x plus 1. All right, so that's what that factors to be. So the factored form of this entire polynomial that we started with is this piece right here, but I also can't forget about the x that I pulled out at the beginning, right? Because x minus 5 times x plus 1, this piece right here, that's just what was left inside the parentheses. That's all that. I just took this thing in the parentheses and factored it to become this. So I can't forget about that x at the very beginning. So the final factored form is x times x minus 5 times x plus 1. And this is my final factored form of this polynomial. Okay? So let's do another example. So same idea. I want to see if there's a greatest common factor that I can pull out. So I'm looking at this polynomial to start. I'm looking at each of these terms and asking myself, can I divide anything out of both of those things? Okay, well, I see that they're both divisible by 3. And they both have y's, right? I want to take out as many y's as I possibly can. This one's got 5, this one's got 3, so the most I can take out is 3. So I'm going to divide out 3y cubed, right? Because y cubed is the most I can take out. If I divide everything by 3y cubed, I'm going to have y squared minus 16 on the inside there. 48 divided by 3 is 16. Y cubed divided by y cubed is 1. Okay. So then I look at what's left inside the parentheses, y squared minus 16. And I ask myself, can I factor that thing anymore? Y squared minus 16. Well, maybe you recognize this as a difference of squares, right? This is a difference of squares pattern. So if I think about the square root of both of these things, I could write it as y squared minus 4 squared, okay? And if you remember what that looks like, we'll come in and finish it down here. The general form of a difference of squares factoring looks like this: a plus b times a minus b. I've got a is y and b is 4 from up here, right? So this thing factors to become y plus 4 and y minus 4. Okay, so y squared minus 16 can factor to become this piece down here. So my final factored form, remember that is the GCF that I took out at the beginning, 3y cubed, times what this thing in the parentheses ended up being once I factored it, which is y plus 4 times y minus 4. And this is going to be my final factored form. Okay, so I can't forget about the GCF that I pulled out at the beginning. All right, so I pulled out a GCF, I looked at what was left inside the parentheses, factored that a little bit more, got it down to here, okay? And then I just put the GCF in front of that whole thing, and I'm good to go, okay? One more type of problem for this video, and that'll wrap it up. So let's say that I'm given a factor, okay? So let's just think about numbers for a second. If I know that 3 is a factor of 24, I could divide 3 by 24 to find what the other factor is, right? I would just do 24 divided by 3, and that gets me 8. So I could see that the factor that corresponds with 3 is 8, and the way I would do that is by dividing, okay? We can also use that same logic, that same process with polynomials, okay? So we can use division to start the factoring process when we've got an ugly polynomial, okay? So let me give you an example of what I'm talking about. This problem says, given that x plus 3 is a factor of this polynomial, write the polynomial in completely factored form. So maybe you remember when we talked about division, that if you divide two polynomials and you do not get a remainder, that means it's a factor, all right? So I'm told that x plus 3 is a factor of this thing. So that should mean that if I divide them, I don't get a remainder, okay? So I'm going to go ahead and do that. First thing we can do is divide the known factor out of the polynomial. So that just means I'm going to divide x plus 3. I'm going to divide 4x cubed plus 9x squared minus 19x minus 30 by x plus 3. Okay? And I'm going to use synthetic division because it's easier. So I look at this thing, I flip the sign, -3. Okay. I have my coefficients right here. I'm not missing any terms. So it's 4, 9, -19, and 30. All right, so here we go. Let's do some division. Drop the 4. -3 times 4 is -12. So I multiply and then add. That's -3. Multiply, +9. Add, -10. Multiply, -30. Add, that gets me 0, right? And that makes sense. That makes sense because my remainder should be 0 if this thing's really a factor, right? So that works, okay? So if I divide this out, I end up with 4x squared minus 3x minus 10. Again, I know that this is a squared because my initial polynomial was a third degree. So I just bump it down 1. It becomes 4x squared minus 3x minus 10, okay? So what that means is that I can rewrite this initial polynomial as 4x squared minus 3x minus 10 times x plus 3, right? The factor that I was given at the very beginning. I just divided it out, okay? So if I multiplied these things back together, I would end up right back here, okay? Now, the reason that I did that is because now the thing that's left inside the quotient that I'm left with after I divide out, I can factor that thing, right? That's what I'm going to ask myself next. Can I factor this quotient anymore? Okay, so let's go ahead and let's think about that. So let's do it down here where there's a little bit more room. So 4x squared minus 3x minus 10. I'm going to see if I can factor this thing anymore. It's quadratic, so let's go ahead and try it. A times, well, first, there's no GCF, right? There's nothing I can pull out, so I can start A times C. That's negative 40. Now I need two things that multiply to negative 40 and add to negative 3. So we could use negative 8 and 5. All right. This is a case 2 example, right? The leading coefficient is something other than 1. So I'm going to have to do my factoring by grouping process. So it's going to be 4x squared minus 8x plus 5x minus 10. So into grouping, I can divide a 2x out of this piece. 2x minus 4. Actually, I could divide more than that, right? I could divide 4x out of that. That would get me x minus 2. There we go. And if I want to divide something out of here to make it match x minus 2, I just need to take out 5. Okay, so then my factor equation is the repeated factor, x minus 2, times the two GCFs put together, 4x plus 5. So here's my factored form of just that one quadratic up here. So let's go ahead, it's x minus 2 and 4x plus 5. Does the quotient factor more? Yes, it does factor more. I can factor it into x minus 2 times 4x plus 5. Okay? So now, we want to write the fully factored form, right? In order to be written in complete factored form, I have to include the given factor in my answer, right? This factor that I was given up here at the very beginning, x plus 3. So it's x plus 3 times x minus 2 times 4x plus 5. Okay, each of those pieces. So now I'm completely done, right? If you wanted to check yourself, you could multiply all these things together, right? You could double distribute and then triple distribute, and you should end up back here where we started, okay? So that is how we factor a polynomial using division to get us started. And practice that a little bit more in class. All right, if you have any questions, feel free to shoot me an email, and I'll see you guys next time.